about the feed-forward propagation in the multiple layers. This is probably one of the most important concepts in deep learning and neural network, and also it is very simple. Let's quickly have a look at it. So, in this slide, I have created a 5-layer neural network. Out of these, three layers I have used, and two activation layers I have used. There are two non-linearities over here, and the input to our neural network in this case is x, which is n-dimensional vector comprising of real values, which we denote with this r. And this vector x goes into this layer 1, and the output of the first layer is a1. So we have A1 as the output of the first layer. Now what happens in the first layer? Let us understand that we have a function of x and w1. Now this can be a fully connected layer or a convolutional layer and so on. So let's think that it is a fully connected layer. We have a linear function, which means it will be simply w1 and x. But to take it general, we are saying that the input x is taken in by this layer 1, which also has weight parameters w1 and a function f over x, and w1 is computed and we get the output a1. So this was the job of the first layer. So the first layer has done the job and passed the output as a1. Now in the second layer, we have an activation function. Let's call this activation function as g. Here there are no weight parameters. It simply takes the output of the previous layer, and then it is giving another output as A2. Similarly, now we have the output A2 of the second layer. Similarly, the third layer, which could again be a layer which has learnable parameters. For example, a convolutional or a fully connected layer, and the input to this layer is A2, right? So it takes the input A2, and also it has weight parameters W3, which we will compute a function over. And the output of the layer is A3. So the layer is, the output A3, now it is passed to the next activation function, right? So here we had, A2 and W3. And the output of this particular layer is A3. That is what we have seen. Now we do this again for the next layer. Here there is another activation layer. So it has no learnable parameters, no weight parameters. It simply computes the function over the output of the previous layer A3 and gives the output as A4. And finally, so we get this A4 as the output of the fourth layer. And then finally, the last layer, layer 5, takes in the gives out the output, right? It computes the function over A4 and W5, right? And gives us the final output O, which connect another network, right? So this is how the forward propagation of neural network works. It is pretty simple. It is simply a composition of functions, right? Suppose we start with the x, then it is transformed into this quantity which we call a1 here by the function which is encoded in the first layer. Then the output of a1 is put into the next layer g, right? So then we have this much, which is then a2. Similarly, the output of this is then put into the next layer, which is then again a learnable layer 3, and we get the output A3. Then this output is put into the activation function, and finally the output of the layer 4. Then we put it into the activation, then we put it into the function K. So finally we are getting the output. The output is represented as O over here. Clear? So this is the forward propagation. It is pretty straightforward. You simply take the output of the previous layer and you put it into your current layer. Your current layer does something with the input and then gives you another output. So this is what happens. This happens to be a composition of function. Note that because of the non-linearities and because of this composition of function, it is able to model any function. So it can essentially approximate any given function in theory, and there is theorem which have looked at the universal approximation theorem. So this is what the neural network is doing. It is approximating the function that we are trying to learn. Now we also know that there is a loss function. A loss function which we have already seen quantify our happiness or unhappiness that we have with our current output. So we got the output O, but the true output of the ground truth, the target was Y. And now we have a function L over O and Y, which quantifies how good is our O. Yes. So this is called as the loss function. And the output of the loss function is always a scalar. We have seen this. So the loss function takes in two vectors, but the output of the loss function is always a scalar quantity. So just to put that in that, you have your input that gives you an output. You also have a target, right? Or the ground truth. And the loss function takes both the targets and gives us the score. It will take both and gives us the score. Right. So this is what the more information about feed forward and how it is being carried out in the multiple layers.